Hi, welcome back to my channel, and in this video we're going to solve this problem. This is JEE Advanced Physics problem, and you have these two beads each of charge q and mass m on a horizontal frictionless non-conducting circular hoop of radius r. One of the bead is glued to the hoop at some point while the other performs small oscillation about its equilibrium position along the hoop, and the square of the angular frequency of the small oscillation is given by okay, so we have this setup right now. The first thing whenever you're solving a problem, you want to have like a mental picture what you need to do or what kind of information there is, so you can start visualizing or having some kind of strategy. So if I look at this problem, they have the same charge, so they're going to be a repulsive force and a repulsive Coulomb force, and the question is asking about the small oscillation. So this is a simple harmonic problem, and it's talking about this oscillation so on a loop. So there kind of need to be a restoring force, which we know the Coulomb force is going to be towards the outward, because this is repulsive, and but that Coulomb force is not going to be able to help the with the oscillations. It's going to be the one that is restoring force, that is tangential to this Coulomb force. So we need to find the tangential component of that Coulomb force. Okay, and then once we know f is equal to minus kx, that is going to be our force, and the we know the angular frequency is square root of k divided by m. So we have this mental picture how to get this angular frequency, but the only difficult part here is the setup. Okay, there's nothing else that make it difficult. It's just the setup, and you need to get over with this the block in your mind that this is a complicated setup, so it's gonna take a little bit of more of an effort. It's not gonna be not gonna be very hard either, but also not gonna be very easy. So you have to kind of think a little bit about solving this problem. So let's solve this problem. And first thing, whenever you have such kind of problem, is to like get a uh, create a picture, like create a diagram and see what is happening, and that will help you in solving this problem. So let's do that. Okay, so let's see. We assume that this radius is the first bead is here. Let's say this is a point A, and this is the first bead. This is the center. So one of the things you need to think about is where is the equilibrium point. So the equilibrium point where there will be like the minimum repulsive force, and you can see the minimum repulsive force would be here. So at the other end of the loop, so the other bead will be oscillating around this position, right? So let's say the bead is here. We need to find the restoring force, right? So we need to be more careful. So this is the force is gonna be, this is bead A, this is bead B, let's say this is origin. So if you think about it, there's gonna be a repulsive force here. So the basic idea is we need to find the tangential component of this repulsive force. Okay, that will help in our this problem. Okay, but okay, so let's say this is our x-axis. So let's say this is my theta, right? Okay, so this is going to be theta. This is radius r. This is radius r. So this is going to be theta because this is a isosceles triangle, and this is going to be pi minus 2 theta. Okay, so what do I need to calculate this force? You need a distance, right? So you need to find out what this distance is. You need to find out what this distance is, and we know the radius of these two, and so basically we're going to apply the cosine law, and the way we apply cosine law in this case. So I want to find this. Let's say this is my x, right? So x square is going to be r square plus r square minus 2 r square cosine of pi minus 2 theta. Okay, so x square is, so this become 2 square 1 minus cosine pi minus 2 theta. So this is lying in second quadrant, and this is going to be plus because cosine is negative in the second quadrant, and then this is pi, so this is just going to be cos 2 theta. So you can apply the trigonometric identity, and this is going to be cosine theta minus sine theta square. I just remember it like that. I don't like remembering thing. I would, so this you can change it to 1 minus cosine, so this is gonna be 2 cos theta square minus 1, and this one cancels out, so you're left with so you're left with 4r square cos square theta. So this is r square, but we also need to find the r square anyway, so I think that works out, because if you know about Coulomb force, so now the Coulomb force is going to be 1 over 4 pi r cube, q square over r, in this case is x square. Okay, so let's go. I don't know. So this is going to be 4r square cos square theta. So this is the force that is going the other way. Um, okay, so now we need to get the tangential component, and the tangential component would be, okay, so now you have this. Okay, so now you have this answer. Now for the small approximation, so you can say small oscillation, which means cos theta is 1 and sin theta is theta. So now let's see how our force changes. So force changes as 1 over 4 pi r, right, q r square theta, right, theta. And okay, so now what we need to do is we need to change this theta to x, because the oscillation happening in this x direction, and we need to be able to change that. And when we look at this x, right, so if we just go here, right, the x would be whatever this distance x. Okay, so now we need to find this y. Okay, so y would be, so we want to find this y, and that can be found using the radius formula, where this okay, so this would become 2 pi, right? So this whole using this angle, this using this kind of arc, we know y would be 2 theta times r radius. So uh, yeah, so because this is oscillating in this y direction, so we need to find this displacement, and so we can plug that over here, theta, where this theta is equal to y over 2r. So y is equal to 2r, or this is 4r, this is 4r. So now we have become 4r cube, 32r cube, and this is y. So the restoring force here is, this, and this is rk. So the restoring force here is this, and this is rk, and we know omega is square root of k over m, and the omega, you want to find the square of omega, that is k over m, and that becomes 32 pi sigma r cube divided by m. So the answer is B. So I hope you like this video. If you do, give the thumbs up, and I will see you next time.